Hi, I, Dr. Emmanuel John Raja, welcome you for the session on BGP4 aggregation. One of BGP4's main improvements over previous versions of BGP is its capability to handle CIDR and supernetting. CIDR stands for classless interdomain routing. Aggregation applies to routes that exist in the BGP routing table. This is in contrast to the network command, which applies to routes that exist in the IP routing table. Aggregation can be performed if at least one more specific route of the aggregate exists in the BGP routing table. Cisco Systems offers a variety of ways to manipulate aggregates to make sure that every need on the internet is fulfilled. In this session, we first examine the simple aggregation technique and then move on to little more complicated scenarios. Let's look at a case in which an aggregate is advertised and all its specific routes are suppressed. This is usually done when the more specific routes do not offer any extra benefits such as making better decisions in forwarding traffic. The figure shown in this screen illustrates a situation in which all the routing updates are lumped into a single aggregate. Suppose that Autonomous System 100, which is shown on the left side on the topology, has the subnet ranges 172.16.00/24 up to 172.16.15.0/24. This includes 172.16.0x, 172.16.1x, 172.16.2x, and so on. The list of specific prefixes can be summarized in the range 192.16.00/20. You could see such aggregated route is exchanged to Autonomous System 200. This aggregate of 172.16.00/20 is sent out and all the or more specific prefixes are suppressed. A number of situations exist in which an autonomous system will send out an aggregate as well as its more specific routes. This usually occurs in situations where the customer is multi-homed to a single provider. The provider would use the more specific routes to make better decisions when sending traffic towards the customer. At the same time, the provider can propagate the aggregate only toward the network access point to minimize the number of routes propagated to the internet. Look at the topology here. Autonomous System 100 is multi-homed with provider Autonomous System 200 via the SF and NY links. Autonomous System 100 can send Autonomous System 200 the aggregate 172.16.00/2 only, or it can send the aggregate and all the more specific routes, any one of these combinations. If the aggregate only is sent over both the SF and NY links, traffic from Autonomous System 200 towards Autonomous System 100 will always take one link or the other. This arrangement creates an unbalanced traffic load. So how can we solve this? To balance the load, Autonomous System 100 sends the aggregate and all the more specific routes. Different metrics could be sent for different routes on each of the links. This way, based on the traffic network number, Autonomous System 200 can decide whether to use the SF or NY link when trying to reach Autonomous System 100. To avoid complicating routing tables beyond the provider level, more specific routes from customers are usually stopped at the provider level. Autonomous System 200 would propagate only the aggregate 172.16.00/20 towards the network access point and suppress the more specific routes in this case. Usually, providers like to minimize the configuration and administration. In this situation, a dynamic approach can be used to stop all the more specific routes from being propagated to the network access point NAP. How can this be done? It's possible. This is done by having autonomous system 100 tag all the more specific updates with the community attribute no export while leaving the aggregate as is. When autonomous system 200 gets this update from autonomous system 100, it will recognize the community assigned to autonomous system 100's specific routes as a request not to forward the updates to the external peers. In this case, it is NAP. The aggregate will be propagated as usual to the NAP and other peers. In some situations, a subset of the more specific routes need to be advertised in addition to the aggregate. Look at the figure. Here, autonomous system 100 is multi-homed to autonomous system 200. Autonomous system 100 would like the networks near SF to be accessed via the SF link and the networks near NY to be accessed via the NY link. Let me explain to you how this could be achieved. Initially on the SF link, advertise the aggregate and the SF networks only, and on the New York link, NY link, advertise the aggregate and the NY networks only. In this case, autonomous system 200 can only reach SF networks via the SF link and the NY networks via the NY link. Networks in other locations could be sent on both the links or either link. In case of a link failure, all the networks can still be reached by following the aggregate route, which is advertised on both links. The no export technique can be used to propagate only the aggregate to the NAP. Moving on. The downside of aggregation. Aggregation causes loss of information because the attributes of individual routes that form the aggregate will be lost. As already discussed, BGP defines an autonomous system set, which is a mathematical set consisting of all elements contained in all paths that are being summarized. Examples of such elements are the autonomous system path and community attributes. Using autonomous system set with the aggregate will cause additional route instabilities due to the fact that changes in the attributes of the individual routes being summarized will now translate into changes of the aggregate itself and will cause the aggregate to be constantly withdrawn and updated. Some situations require that the attributes of the aggregate be changed. One such situation is when the aggregate contains some unwanted attributes that are inherited from the routes it is summarizing in case of autonomous system set. An example could be no export community attribute that the aggregate got from one of the more specific routes and that causes the aggregate not to be exported to other autonomous systems. Another situation that calls for changing the attributes of the aggregate is to reflect a level of preference for a certain aggregate. An example would be a customer's advertising an aggregate via multiple links to a certain provider. The customer might like to have the aggregate go out with different MEDs on different links to influence the entire point into the autonomous system. Cisco has developed techniques to let the users modify the attributes of an aggregate. We have seen that with autonomous system set, the aggregate will contain a set of all attributes including autonomous system numbers that exist in the individual routes being summarized. If the aggregate is summarizing routes that come from different autonomous systems, it becomes useful to specify which routes are being included in forming the aggregate. This would help in a hub and spoke situation in which each of the leaf autonomous systems contains a separate subset of the aggregate that is originated by the hub. When forming the The hub autonomous system would exclude the more specific routes that belong to the leaf autonomous system that needs to receive the aggregate. The aggregate received by the leaf autonomous system would not contain the autonomous number of the leaf autonomous system, so it would not be discarded. The figure on the screen gives an example of where this could be used. Autonomous system 3 is a hub autonomous system receiving routes 192.68.11.0/24 and 192.68.10.0/24 from the leaf autonomous system 1 and leaf autonomous system 2 respectively. Prefix 192.68.11.0/24 has an autonomous system path of 1 and 192.68.10.0/24 has an autonomous system path of 2. When the autonomous system set, that is AS set, aggregate is being formed by autonomous system 3 based on all the more specific routes, the autonomous system path information would be 1, 2. The aggregate itself is sent back to either autonomous system 1 or autonomous system 2 would be discarded for loop prevention. Autonomous system 1 would see its autonomous system number in the autonomous system path information and would drop the update. The same is true for autonomous system 2. If you could specify which more specific routes can form the aggregate, you could, for example, specify that the aggregate is to be formed based on 192.68.11.0/24 only. This way, the autonomous system path information would be 1 and would not contain autonomous system 2. The aggregate could now be sent back to autonomous system 2 with no problem. Autonomous system 2 can use this aggregate to forward traffic to all the destinations in autonomous system 1. In this section, we will see how an aggregate can be generated without propagating any of the more specific routes that fall under the aggregate. In the network illustrated in the topology given on the screen, RTA is sending prefixes 172.16.220/24, 172.16.100/24, 172.16.10.0/24 and 172.16.65.0/26 towards RTC. The configuration in the given example shows how RTA can aggregate all these routes into a single prefix 172.16.00/16 and send it to RTC. This of course assumes that autonomous system 3 is the sole owner of the class B 172.16.00/16. RTF is also doing the same aggregation on its end with a configuration similar to RTA. RTA's configuration uses aggregate address command to aggregate all the more specific routes of 172.16.00/16 into a single address. RTA's BGP table is shown in the screen. It indicates that a new aggregate 172.16.00/16 has been originated by this router. Next hop is 0.0.0.0, whereas all the more specific prefixes have been suppressed. Note the S at the far left. In this case, the same results could have been achieved by using auto summarization. The output of RTC's BGP table is shown in the screen. It shows that the only prefix that was learnt from RTA is the aggregate 172.16.00/16. Because RTF is also performing the same aggregation, RTC will also learn an aggregate that is originated from RTF next hop RTD via autonomous system 2. Having control over which individual prefixes form the aggregate is very useful in determining which attributes the aggregate will carry. If you could exclude prefix 192.68.11.0/24 from being part of the prefixes that form the aggregate would not inherit the no export community attribute. The advice map is yet another form of a route map that allows us to form the aggregated route based on a limited selection of the more specific routes. The figure in the screen illustrates the network topology for the scenario which I am going to explain. In the figure, RTA and RTF are getting routes 192.68.11.0/24 and 192.68.10.0/24 from autonomous system 1 and autonomous system 2 respectively. If RTA and RTF are to aggregate these routes into 192.68.00/16 using the as set autonomous system set option, the aggregate cannot be sent back to either autonomous system 1 or autonomous system 2 because it contains 1, 2 in the autonomous system path. This is due to the normal BGP behavior in detecting loops. Assume that the required behavior is to have the aggregate 192.68.00/16 sent back to autonomous system 1 and not to autonomous system 2. The solution is to have autonomous system 1 not be part of the aggregate's autonomous system path. Then autonomous system 1 will not drop the aggregate. This could be achieved by having RTA and RTF form the aggregate based on 192.68.10.0/24 prefix only using the advertise map option. By permitting prefix 192.68.10.0/24, the advertise map causes RTA to base its aggregate calculation on 192.68.00/24 only. Thus, 192.68.11.0/24 is not included in the formation of the aggregate. The show IP BGP command is issued and the result is shown on the screen. The output is on the screen illustrates that the aggregate's path information is now 2 and not 1, 2. This means that the aggregate can now be advertised to autonomous system 1 because the autonomous system path does not include autonomous system 1. Autonomous system 2 will not be able to receive the aggregate here. Hope you have enjoyed this session. That brings the end to the session. We'll move on to learn on route reflector in the next session. Thank you.